explain what that means. It's very relevant in today's lecture, especially because we'll be talking about Pygame sprites as well, which utilize inheritance when you're using sprites. All right, so let's start with wrapping up methods. So here's a quick reminder. A method is like a function. However, it has access to member variables of the object, and this keeps code organized. So remembering from last time is like a method is a function that belongs to a specific class, and you can call that using the dot operator on the left here. If you had a function, it would be defined with no indent at the top of the or anywhere in the file, and then you could call that method like you do a method, or that function like you do a method, but without the dot operator. All right. And another reminder about self. So when you're defining a method for a class, the first parameter of the method is always self. So do not forget that. It is very important. And then also calling a method from outside the class, self is automatically added for you. So for example, if we had this method called method name here for my class, my object.method name would call that method for us, and we don't have to include the self. And so we can also use self within our classes to access other methods, kind of like how we access the properties from our constructor. On the right there, we see self.x, self.y, and we can, if you remember from last time when we were creating our platform and our player, we could access those in other methods. You can do the same thing with methods within a class. So here, for example, we have the ball class. It's calling its own method move y and move x to achieve move diagonal, as you can see here. So to access a method within a class, you'd use self.that method. So for example, self.move x, self.move y. Make sure you use that self as well. It's very important. And so that brings us to our first quick question. How many times is self missing from this class? So we have the fruit class, and we have a couple of methods in there.
I'll give it like 30 more seconds.
Sounds good, yeah.
All right, I'm gonna close it up, get your answers in.
It's a kind of a tricky one for sure. All right. So we have most of the class not actually getting the correct answer here. So maybe I'll just do a quick demo here of what went wrong there. Okay, so it's kind of a tricky question a little bit. There's a lot going on here. All right. So we have class fruit. And so the correct answer would be 6, actually. And I'll explain to you in a second here. So remember how important self is to a class and how it accesses its members and its properties. So for example, in this constructor function, even in the parameters list right here, we would have to put a self in there. right? So that's one. Then we have a self dot fruit name. That's also one that we'd need to include. There's a self dot color that we need to include. So there's 3. We also have a method here. And I mentioned just a couple slides earlier that you have to include self in your methods on your class as well. Doesn't it depend on what we're trying to do, because there's also class functions, right, which don't use the self parameter. So these are defined within the class. So these are methods. Methods do require the self, even if you're not using it. And there's some fancy ways to get around that in Python, but we're not going to worry about that though. So you would need, especially because we're calling byte inside the eat function, we need that self to act, or that self parameter to call byte from. So there's 1, 2, 3, 4, 5. So it's the last one we have is byte down here, which would also need a self. So this is the correct answer is 6.
Oh.
Does this make sense? Does anybody have any issues? Here, for example, because like it seems kind of confusing when you call byte when it doesn't use any of the actual functionality there. But if you call without giving it self, so here, let me just open up a terminal. We can see that byte takes 0 positional arguments, but 1 was given. That one that was given automatically is the self variable. So when you put that in and save, you get crunch. So it works. So it is required. Despite not really using it in that function, you still are using it. All right, I hope that makes sense for everyone. So we'll continue on here. All right, so welcome to a topic that gets taught in university. I mean, it's a pretty big, important part of programming in general, but we'll try to keep it as simple as possible here for this lecture. All right, so what is inheritance? Inheritance allows us to inherit all variables and methods from another class. It is used to extend the functionality of an existing class without typing it all over again. So for this example, we're going to pretend we're making our own version of Pokemon to see why it's useful. So much like a lot of constructs in programming, a lot of it is to be able to reuse and have little like code reuse and organizing our code. So inheritance allows us to kind of do that. So this is without inheritance. So say we had an Eevee, a Flareon, a Glaceon, and a Leafeon, and they all have a name and they all have a type. And then they all can growl and they all can tackle. But only some of them can use some of their special moves like Ember, Blizzard, Razor Leaf, for example. So there are those highlighted properties and methods there are things that they share together. They can all do that. But if we implement it how we know how now, that would just lead to us re-implementing a function for growl, a function for tackle, or a method, and then a property for name and a property for type for each of these. So it'd be a lot of writing of the code, the same code over and over again, which is something programmers don't really like to do. We like to make things more streamlined typically. So with inheritance, the idea behind it is that we have a class Eevee that has a name, a type, a growl, and a tackle. A name and a type property, a growl and a tackle method. We can have Flareon, Glaceon, and Eevee, or Leafeon, sorry, can inherit from Eevee, and it'll get all of the implementations for those methods, and it'll also carry on its properties as well. So we only have to write the code for the new moves in this case, because we've written growl and tackle in our Eevee class, and Flareon, Glaceon, and Leafeon would inherit those methods from that Eevee class. So for example, Flareon takes EV as a parameter when defining the class. So you see from above here, we have a base class of EV. And then below we have a Flareon, and in parentheses, we take that EV in. That's where that's coming from. And then we use super.init to initialize all member variables of the EV class. So basically what that's doing in that line of code is it's calling the init function or method from that EV class above. So it's like importing a class into another class. In a way, it's a little bit different because when you import a class, you like into a file, like there's a lot going on there with inheritance. Like you typically import to use stuff, and I guess you would import to use stuff in. So it's like it's similar, but it's a different idea, if that makes sense. It's a little more complex, and it can get a little more complex. So in this example, we've defined tackle here for EV, and we can use tackle on Flareon actually without actually writing that code again in Flareon. But we can also access its name and its type from our Flareon class as well, even though we didn't do self.name equals name in Flareon. That gets handled because we called the init from the EV class. I hope that makes sense. Maybe I'll do like a quick demo here. One sec. I moved it over to this screen, sorry. All right, there you go. So say, ignoring the EV stuff, we have a base class fruit. In inheritance, you can use the superclass methods when referring to the child class. That's the main difference, I think. When importing, you're just bringing methods from another class to use within the second class. Kind of, yeah. Like, so say if you define functions in another module and you wanted to use them in your class, like say from random, you could import those. But it, like, to my knowledge, I'm pretty sure you're not like inheriting from the random class typically. If there is one, I'm not entirely sure. But for example, in this case of fruit, we could have like a banana that inherits from fruit. So that's how you'd kind of read that. And then what's important too is to define an init function that takes the same things, or it doesn't have to take the same things. For example, it could just take self, and then we could call super.init and provide banana and yellow itself. So we could do, oops. And then we could call banana.byte. Or we could make like a new one, like peel or something, and print peel. But you could also byte. So I'm just going to demo that here. Assuming I've written my code correctly, let's just try. Okay, we haven't. Requires a super object. So yeah, this is not a super object. This should be a call. This should be a method. Yeah. Doesn't this super init need? Yeah, it does. Sorry. That's my bad. So there we go. So we print crunch because banana can access this method from fruit because it inherits from it. So it's called byte without defining it in its class, but it also called peel, which it defined itself in its class, right? But then if I try to do apple.peel, you would get an error. Fruit object has no attribute peel. So I hope that's a bed. Like, was that a good example, or is there more that does anybody have any questions at all? Because we're going to be going into an exercise here in a bit. If not. All right, I'm just going to take that as good then. So kind of like what I was just doing now with fruit and apple, Flareon now has a name and a type just like Eevee. So when you're calling or creating a Flareon object, you're using the Flareon constructor and still providing it the name and the type, because in this constructor, we've given it that. Flareon can also use tackle, even though it was only defined in Eevee, kind of like how I showed you with the apple and bite. And Flareon can use Ember as well, but that's a new method that it defined itself for its class. It makes sense because Eevee doesn't know how to use an Ember, but maybe Flareon would. And that brings us to our first exercise of this session. So what you guys are going to do now, or what you all are going to do now, is create a class, Jolteon, that inherits from Eevee and has the following methods. It'll have a constructor and an init that takes in a name and a type. And then it'll have a thunder method as well. So some hints for that: make sure you use the super method or a super function to init your base class inside the init method of Jolteon. And Jolteon also inherits tackle from Eevee. So make sure you remember that. So I think maybe 15, 20 minutes on that, Rohit.
Yeah, it should be good.
All right.
Hello, Brian. Is your mentor Pradham? Perfect.
Everything good, Rohit?
Yeah, I'm just assigning Brian to his room. He just joined a bit late.
Okay.
Yeah, you should be able to join now.
All right. Welcome back. I hope everybody had a good chance to get some of that done there and to learn a little bit more about inheritance. But we'll take this and we'll do it now. I'll implement an EV or Jolteon. All right. So to inherit something, you need to first pass it in to the class there. You then have to define a constructor that takes in a name and a type. We then have to call the super method. And then put in the name and the type. All right. Then we have thunder method here. And with that, we'll print. Oops, 1 second here. All right, so this should work. All right, there we go. All right. Oh, this is the wrong one. Okay, should be the ev.py class. There we go. So Jolteon used tackle, Jolteon used thunder. I hope everybody got to give that a shot there. But yeah, if there's any questions, just please let me know. But we'll move on now. We'll continue to like dive deeper into inheritance, but maybe not with the EV topic. We'll do more based on Pygame sprites. No, sprites don't have anything to do with fairies. They have been chosen for the pun, but you know, that's fair enough. All right. So Pygame sprites make it easy. So a sprite is any object on the screen that uses an image when it is drawn. So here's some examples. You could use sprites for players, enemies, vehicles, bullets. The Pygame sprite class allows you to make your game character really cool by adding sound, images, animations, and behaviors. So when you're creating your own sprites, you'll be inheriting from the Pygame sprites class that exists in Pygame. So for example, if we were making a fairy sprite, we would inherit from the Pygame sprites class. As you can see here, it has properties for an image and for a rectangle. So it keeps track of all of that for you, which makes it really easy, because if you were to implement your own sprites, basically, you'd have to do this all yourself. And then it also, this allows you to handle it yourself and keep track of it in a more organized way. And then it also has methods that allow you to draw and update those sprites. So what is a sprite? A sprite is a computer graphics term for any object on the screen that has an image. When you play a 2D game, all the objects you can see on the screen are sprites. So Mario, for example, is a sprite. Can anybody point out any other sprites on the screen? Pipe. Yes, definitely. Mushroom, Goomba, for sure. Yeah. Yeah. So these are all sprites for sure. So as you can see there, those we got blocks as sprites, pipes as sprites, Goombas as sprites, the ground is sprites, everything's sprites. So as you can see, there are properties that belong to these sprites. So for example, you can use getRect to create a rectangle with the same width and height of the image. So if you look at an image, you can imagine a rectangle around that image that holds it, right? And so the getRect creates an imaginary rectangle around the image. And it always stays within the coordinates of, or with X, it always starts with XY coordinates 0, 0. Sorry. So as you can see, this owl sprite is in this window here. So here's an example of creating a sprite class, right? So first off, notice how we're importing Pygame again. So kind of like what we were doing last class, but we're doing this so that we can use the pygame.sprite class. So we're kind of doing the same thing that we did with Eevee and Jolteon here, but we're using a different class to inherit from. So like that, we are calling the super method, and then the constructor from the pygame.sprite class, which I'll just call sprite from now on because it's a lot. But and below that, you can see we're getting the image location from os.path.join on the strings assets and fairy.png. I'll explain that a little bit later, but basically what that's doing is getting the fairy image from an assets directory in your file structure. Then we load the image below that, pygame.image.load from the image location, and then we convert alpha there. Then we're setting our rectangle to, like I was talking about in this slide over here, we're doing self.rect is equal to self.image.getRect, which allows you to track the image's coordinates. And then we can manipulate that rectangle, and that'll update where our image exists on the screen as well. So here's the example continued. Here's a method for updating. So from here, we can call anything we want in the update method, but it's for updating the fairy class that we've been creating back here. And then we also have the this move class, which we kind of did before, right? When we were moving the players and the platforms. So this is a method of the fairy class, and it would be used just like we'd done in the past lectures to update the fairy's X and Y coordinates. So here's like a small exercise. We could download the fairy PNG image, and I'll post a link in the chat, but we can save that file exactly as fairy.png, and then we can create a folder called assets in our current working instance of, or our current VS Code, and move fairy.png into that folder. So I'll just show that right now. So here, I'll copy this. I'll post in the chat. But basically, I'm going to save this image as, and I'll save it to session 4, which is where we're in, into a new folder called assets. And then I will save it as fairy. And that should just save as a PNG because it is a PNG. So there you go. But if you didn't do that, you could come in here, create a new folder. I'm not gonna do that, but you could name it assets, drag and drop whatever you want in there as well. All right. So that's what that line of code was doing over here, was it just assumed in the directory that we're our main is located in, that there's a file folder called assets, and then in it an image called fairy.png. Yeah, I'm sorry. I'm sorry if you thought there was something on the screen. It is just my lame costume. All right. So now we can begin to load the images. So we can import OS, the OS module, which is something that Python comes with, and then use os.path.join to get our computer files. And then so when we use the function or the function pygame.image.load, it'll look for a fairy PNG in the assets folder. And then get_rect would turn our image into a pygame rect that we can use, and like we've just been using for every session before this, basically. All right, so that leads us to our second quick question. What is missing from this sprite that would make it not run properly? I think we'll give it like 10 more seconds.
All right, closing it in 5 seconds. 2, 1.
All right. So it seems like most of the class got it right here. So what's missing from this example is just that it doesn't have the super.init constructor called. So this would not actually compile, or it wouldn't run. Sorry, not compile. So yeah, that's the correct answer. You don't actually need a move method. And there's also, I believe there's a draw function already inherited from a class below, so, or from the sprite class that we're inheriting from. So we don't need to do that either. All right. I hope that makes sense for everyone. Is there any other questions? All right, so we'll talk about sprite groups now. So a sprite group is a container class that is used to hold multiple sprite objects that all do the exact same thing. For example, as you can see in the bottom left, there's some bad guys walking around. So it's kind of like creating any other class. So first, though, to add to a group, you'd have to create an object. So right here, we're instantiating an enemy object. And then we're creating a sprite group using pygame.sprite.group to create a baddies object. And then the baddies group, sprite group, we're adding an enemy to that as well. So, and just as a reminder, or maybe not a reminder, just to note, you should have all of your sprites in a sprite group, even if it's just one sprite. It's important for updating and drawing these sprites. So we'll continue our fairy example here. In our main.py file, we had the following code after clock equals pygame.tick.clock and setup. So we would create a fairy, and then we would create the sprite group and assign it a name, fairies. And then we would add a fairy to our fairy sprite group. So just reiterating that it's important to put your sprites in groups, even if it's just one sprite. And so here we have where we draw our sprites. So we create our fairy like we did on the last slide. We've done all that. We've added it to our sprite group. And then from our sprite group object, notice that it's the sprite group object, fairies, not fairy itself. we're dot drawing it to the screen, and we're providing it the screen variable. So this draws your images sprites at your this draws your sprite's image at your sprite's rectangle coordinates onto the screen, if that makes sense. So this handles all of doing all of that for you. So all you have to do is call your sprite group dot draw to the screen. And then you can also do fairies dot update. So this will call the update method of every sprite in the sprite group. So if there was, like, right now we only have one fairy, but if we had, say, platforms or something like that, and we did platforms dot update, it would draw all of the platforms if we had multiple platforms. So I think it's very key to understand here that we're calling the dot update. There's a dot update, or there's an update method in the fairy sprite class, but there's also an update method in the sprite group class. So we're calling it on the sprite group class in our update section. And so this code will cause the fairy to move 5 steps every time the update section is run. All right, so this begins kind of a long exercise here, but we have kind of a few exercises to get through. So I don't know how much time we can spend on each of them, but let's start with this one. So we're going to edit last week's end of session exercise to be a player sprite rather than a basic player class. You can download the image. I'll get that right now from here on the folder, but right here maybe. What if you don't have last week's project? That is a great question. Do we have any resources that we could give students that don't have?
I think all of the mentors should have access to the code for last week's.
Okay.
So whoever that is, we could just give it to them like that.
Okay, for sure. Yeah. So just ask your mentor when you're in your breakout rooms. So I think what we're going to do is we have multiple exercises here. So we're going to put sprites on the player sprite. We're going to do that the same thing to the platform as well. And then there's a bonus for animating the player, which we might leave till, like, I could do a demo of it next week or something, because I think there's a lot going on here. But we'll see. I'll give it a shot maybe if we have time. So yeah, I think the breakout rooms can be maybe like 25 minutes and try to get sprites onto their classes.
Yeah, so you want to go till the end of session?
Doesn't the session end at 45?
No, 7:30.
7:30?
Yeah.
Okay, maybe we'll do 15 minutes and then I'll try to get it out in 10 minutes just to show them what how it's done.
Okay, sounds good.
All right, welcome back, everybody. I'm going to take a stab at trying to do most of these before the end of the class here. So here's my main.py that I've been working on this whole entire lecture series. I'm going to start with adding a player sprite here. So I'm going to import Pygame to my player file, save that, and then I'm going to inherit from pygame.sprite here. What I'll need to do is not that. I'll need to call super and then init to construct my base sprite that I've been talking about. And then we're gonna need to grab the images the image location. So also what I need to do here is import the OS as well. So I'm going to do pygame.image.load. From there, I'm going to take os.path.join on assets and player.png. What I'll have to do is move my player PNG into this assets folder. And then convert alpha here. And then from here, I'll get my rectangle, which I should remove from up here because I'm not going to be taking that in anymore. We'll be taking an X and a Y. Is going to be equal to the self.image.getRect, which is given to us here. And then we'll set self.rect.x is equal to X. Self.rect.y is equal to Y. And there we go. So what I'll have to do in here is instead of giving my player a rectangle, they now just take in an X and a Y. And then we also need to create a players group, which will be equal to pygame.sprite.group. And then we'll players.add our player to the group. Oh, I also have to technically it should still work actually, but adding an update function is something that you could do. Sorry, but right now we're still handling our player.move here, which will still actually update. And then instead of drawing our character like this now, we should do players.draw to screen. And if I've done everything correctly here, we should see a player get drawn to the screen, but I might have messed something up. Let's go check chat just to make sure. Okay, there's missing 2 width and height. Oh, right, that's because, one sec. That's because our image. Oh, platform. Oh, okay. It's also because I meant I changed how the platform class as well before the lecture started. So there we go. That should actually now work there. But I'm gonna actually comment out the drawing of platforms right now because it shouldn't work right now. That's not the drawing, that's the update. I've in preparation for drawing sprites, I've changed the class a little bit. Platform.append, I'm gonna just comment this out for now. All right. Okay. No video mode has been set. 1 second here. Set alpha. Interesting. Self.image, pygame.image.load, os.path.join assets on player.png. Let me just double check here. In the slides, maybe. All right. So 1 second here. We have our path being set here. Like, so basically I've just in one line grabbed the image location, but we can do that on its own. And do player.png, and this should get us the proper path there. And then set this to that image location. Pygame.image.load. All right. No video mode has been set. 1 second. Maybe there's something wrong with my main file here. Get the PNG into the file. Do you choose the new file? Yes. Pygame.init is being called. Import player from player. I'm not really sure what's wrong here. Display.set mode. .set alpha 0. Screen.fill. Pygame.quit. And I'm using the player's sprite group and everything. Okay. Apologies. I had just had this running and it. No video mode has been set. I have to leave early. Okay. We might have to call it here. Is there a way to expand the image? We'll cover that next time. But yeah, I'm not sure I can actually solve this within the time frame of the lecture here. So I'll put like a thing in the chat and the Discord later this week that shows this off. But so sorry about that, but I've run into some technical difficulties here. So yeah, are we doing, Rohi, are we doing a survey at the end of this lecture?
Yeah, good call. I'll just Yeah, I'll just put this up like 30 seconds.
Yeah, I can put new code in the Discord because yeah, it did kind of get fast at the end there. That's my bad. I apologize. All right, yeah, this content can be kind of difficult. Inheritance is kind of a higher level idea concept, and but it's necessary for moving forward as well. All right, yeah, if you have to leave, go ahead. Thanks for coming, but yeah, if you can have some time here to answer these surveys, that'd be great.
Ten more seconds.
All right. Okay. So we have slow pacing and just right pacing kind of tied with, or like a little bit closer to just right, which is good. But yeah, next time I'll try to get better at I'll get the example a little more tame for next time. And then I'll post some example code in the Discord later. But yeah, with that, that's the end of this session. So thanks for coming. Also, is there any criteria for the final project so we can work ahead? Rohit, do you have any knowledge on the final project?
Yeah, I think I can ask Fanny that. She's like a content development member, and she can see when she can give you the details. So I can actually ask her to put a general message out in the Discord, say that people are inquiring, so that she can probably get that out by, I think, next session if possible.
Yeah.
The details and stuff that you guys would need.
Okay, sounds good. All right. So yeah, that's the end of the session. Thanks for coming, everybody. Happy Halloween. I hope you have a good week at school. And yeah. Bye. I use what do I use? I use Dracula theme for my Zed shell. Bye.
All right, I think that's just the mentors left.
Yeah.
So yeah, went a little overtime today, so we don't need to really do the entire debrief. Just any points that you guys think should be brought to my attention that I can forward to the team.
Okay.
Is there anything you guys got, or was everything mostly good today?
Everything is good. Yeah.
I would say, just like watch the pacing on the exercises, because the time we had in the breakout room, for like the first like EV exercise was like way longer than it needed to be, and then like the last breakout room for like making sprites could have been a bit longer because that's like a more expansive thing.
Yeah.
Like even like in my breakout room with my mentees, we got through like the EV exercise in like 5 minutes, and after that I was just like, all right, let's get started on sprites, and we still didn't cover everything.
Makes sense. Yeah.
Okay, so I think one thing that we can try to do, like maybe on that front, right, is I can try making all of the other like mentors, everybody co-host, so you guys can navigate through like breakout rooms. And if you want to come to like the main room and maybe tell Sebastian if you guys are like, if your group is done, or like you guys can then mention about how stuff is going in the room if you need. So I think that could help control that problem. Does that sound like something I could do, or like we could implement?
Yeah,
Maybe
okay.
I could also join rooms maybe. instead of just
Yeah,
sitting
that
there.
you, because you have the co-host ability too, right?
Right.
Yeah, so that would be even better. Then that's easier. You can just like cycle through the rooms and just
Yeah.
ask and kind of get a pace. Yeah, that's a good idea.
Okay, yeah, next time because I just sit here and like read notes and stuff. So
Yeah. Okay, perfect.
Did anybody
yeah.
spot the error that I was getting? Like, has anyone had that one?
No?
Yeah, that's a good one.
Yeah, I was
did-
trying to figure it out, and I think my code like looked exactly the same as yours. So I would look into that
yeah,
because I'm
I'll
not
give
sure
it-
what your problem is.
I'll give it a shot.
Do you have like a working like version of the code that you can just like go and reference?
Not anymore. I modified it a little too much. I think I then didn't save it, and then yeah. So I don't know. I'm gonna bust it out like after this, basically. Like just figure that out. Then I'll send it to the kids. It's kind of a shame. Yeah, I wanted to get animations in, but this one had like basically like there's quite a lot at the end here for this content slides. Like it's pretty like I thought inheritance might be harder for the students than I anticipated, but honestly, yeah, it makes sense that it wasn't.
Yeah. No, that was fine. I know, little error. So as long as you update that in the Discord, that's good enough.
Yeah.
Yeah. Is there any other questions, concerns, or anything?